Hi, this is Huda Zenham from Physics 2211 Section M, and this is Lab 2. The purpose of this lab is to observe and track the motion of a falling object. In my case, I used a tissue box that is about a quarter full and recorded a video of me dropping the box. I used the program Tracker to track the observable motion in the video, and the coding program GlowScript for the two computational models, one that considers gravity and one that considers drag and gravity. Then I compare the results in a spreadsheet and line graph. So for Tracker, I set the axis origin to be the center of the box and tilted it slightly to the left because that is naturally how the box fell, and used my height as a reference point for the calibration stick. When we run the video, we can see that the program, it considers every position and obtains it into this chart here for every time frame. And then we have a graph here that shows that the position is increasing in the negative y direction because this is the negative y axis. For the coding, we have to initialize our conditions. First, we have the mass of the box, 0.12 kilograms, position, velocity, and time all at 0, and delta t, which is the size of each time step, to be 0.001. And then we have the acceleration due to gravity, which is 9.8 meters per second squared, and the unit vector, which is 1 in the y direction. So for our calculations, we have to go through a while loop that goes through every time step and until the 0.667 second mark, which is the end of the video. And for just gravity in this section, we have to consider that Fnet is only weight force, and weight force is calculated by negative mass times gravity times the unit vector. And then we apply that to the momentum principle, which is updating the velocity and position using these two formulas, and then we advance the clock again to go through every time step. Now when we're considering drag, we have to add that into Fnet. So Fnet is both now weight force and drag force, and the formula for that is negative b times the velocity, and b here we initialized and obtained by plugging in a b so that the last value that we receive from this model matches the one when we run this code. Again, we just use the same momentum principle formulas to update velocity and position, but now we are considering drag into Fnet here. When we run the gravity only model, we see that the object is moving downward, and we have a position and time graph just like in the tracker model, which is increasing in the negative y direction, and we have velocity increasing in the negative y direction consistently. And here with the drag, we have an arrow representing the drag force, which is opposite of the gravity force. And again, we have a position time graph increasing in negative y direction, and velocity, which is not as consistent as the first one because now we have the drag force to consider. When we compare the data, we can see that the model for gravity is quite different from the ones that are gravity and drag and the observable data. The gravity and drag model and the observable data are closely related because in real life, especially with fluid mechanics, drag is an important force that should be considered when talking about real-life motion. When you just calculate things with just gravity, you're not considering all forces. So what does it mean when we're considering terminal velocity? Do these two graphs, the computational models, do they have terminal velocity? And in this case, they don't, because if they did, the curves, the lines would flatten out. And we can see here that the velocity is starting to flatten out in the horizontal direction, but it is not completely. So that means that this model is approaching terminal velocity, but overall, both are not. So what if the object was initially thrown downward, meaning that it doesn't have an initial velocity of 0 like originally, and let's say we have here now negative 2 meters per second. As we can see, the two lines they have the same shape, meaning that they both would have the same terminal velocity. It's just how the speed in which they reach it, because terminal velocity is not dependent on initial velocity. It is only dependent on how there's the balance between the force of drag and the force of gravity. Initial velocity is not considered with this. Thank you and have a great day.